Okay, so last week we went over chapters 9 and 10. So chapter 9, we learned about reading medication labels and the different information and components that are found on those medication labels and how we can pull that information and use it for our dosage calculations, right? Chapter 10 went on to talk about reconstituting medications from a powder and how we can, again, pull information from those labels in order to give us information regarding the dosage strength or the desired concentrations of those medicines based on how much diluent that we add to those according to instructions. And then we were able to pull and use that information to perform our calculations and do our dose, figure out our dosages from all of that information. So based on last week's homework and exams, what questions do you have before we go any further?
There were a few I had trouble setting up the dimensional analysis on.
Yeah.
No, they're like, honestly, like they made no, like on the test exams, it may not, it wasn't making sense on how to set it up because you have to break it down into this and this, and sometimes you can't, discontinue like demos or, so it was confused, it was kind of confusing.
Okay. Anything else?
In chapter 10, verse 6, because there, like, you have to do the 12 TJ. And I don't know, I'm just confused with my answer.
And was that on your homework or the exam?
Homework, okay.
Okay. Okay, so chapter 10, number 6. All right, so let's look at the homework on chapter 10. And it gives you a label of ceftriaxone, and you use that label information to answer questions 2 through 6. So let's just start at 2. And I think most of you have your homework with you. So what is the total amount of ceftriaxone in the vial? What did you find on the label for the total amount?
I answered 2 ml.
Okay, you got 2 mLs. Okay, what in addition to that? How many milligrams is in that vial? 500 milligrams. Okay. How much, number 5, how much diluent should be added to achieve the concentration of 250 milligrams per milliliter? Okay, 1.8. And then number 6 was the question you have. So the provider orders ceftriaxone 50 milligrams per kilogram intramuscular every 12 hours for a child who weighs 12 kilograms. Calculate the volume or the milliliters of ceftriaxone to administer if the vial is mixed with 1 milliliter of lidocaine, and then you round to the nearest 10. So, what?
We worked that one out.
Yeah, I'm going to work this one out so you'll see where we get all that information from and how we work it. So, the doctor has ordered the 50 milligrams per kilogram. So you might want to underline that in your problem, okay? So the order is 50 milligrams per kilogram. Every 12 hours, that's just how often we're going to give it to our patient, for a child who weighs 12 kilograms. Calculate the volume or the milliliters to administer. So X, what I'm solving for, is going to be milliliters, okay? So that's what I'm solving for. If the vial is mixed with 1 milliliter of lidocaine. So we look on that label, and it tells us that if we mix it with about the middle of the right-hand side of that label, 1 milliliter. So if we add 1 milliliter, that gives us a concentration of 350 milligrams per milliliter. Okay, so it tells us in the problem, if the vial is mixed with 1 mil, and that's what we're going to do, then our concentration is 350 milligrams per milliliter.
Yeah, that's why you use that one instead of the 1.8 for 132.
Because they told us to
That's where I'm at. Yeah,
in the problem.
I did not base on this one here, I was just basing the question. Oh, the 1 milliliter, why?
Yeah.
Oh, it didn't say 1.8, oh, okay.
Yeah, it's saying in number 6, it says calculate how much you're going to give if we mix 1 milliliter of lidocaine into that vial. Because it gives us 2 different options. So we're either going to add 1.8 milliliters and we'll have a concentration of 250 per milliliter, or we're only going to add 1 and we'll have a bigger concentration. So you remember last week when we talked about, you know, if we are going to give a shot to somebody, if we're going to receive a shot, we want to mix that in the least amount possible, and it'll be the most concentrated versus adding more diluent to have it weaker. Okay, so
Reading question 5, I just want to follow through and give me this name.
Yeah.
I did not look at this problem correct, so I
Yeah.
was just basing numbers based on.
gotcha. So yeah, you're pulling that label, you're pulling all the information there. So now that we know that this is the concentration we're going to use, let's solve the problem. Okay. So we know that I'm solving for milliliters. Okay. So this is all the notes that I took or what I underlined in my problem or whatever. This is all the information I feel that I'm going to use. So what do I know about milliliters?
There's 1 milligram.
So for every 1 milliliter that I have, it contains 350 milligrams of medication. Okay, so that's what I'm starting with. I want to cancel out milligrams because I only want milliliters left. Okay, so what, and I've used this already. I've got 50 milligrams per 1 kilogram. So I've canceled out milligrams and I've used this information. So I've got milliliters on top, kilograms on bottom. I want to cancel out my kilograms. What do I have left over here? 12. And I'm going to put it over 1 because there's no other information that's related to. Okay? So that cancels out my kilograms. So I have left milliliters on top. Everything else is canceled out. So I know that I've set my problem up correctly. So on the top, I've got 50 times 12 divided by 350. So what's 50 times 12? 600. Does it tell me what to round to in the problem? Round to the nearest tenth, and I get 1.714. So if I round to the 10th, what's my final answer?
1.71.
1.7 milliliters is my final answer.
Yeah, that's you could do it with the 1.8.
Yes,
So I can see if I
Yes.
can really know what it is.
yes.
It doesn't sound like that.
So what we would change if you use the incorrect concentration, it would be 250 milligrams per milliliter. Does everyone have this written down before I'll do it over here for you.
still got to do it on. That's right with the dirt. That's a big difference.
Big difference.
8.6 means how.
Now, I will say that if you, I know this is gonna be very confusing to you, but if in the real world, you said you just killed the patient. You didn't. If you would have got the right answer, you would have killed the patient. Because you're giving them the same amount of medicine, it's just stronger. You're giving them, this is weaker, so you're giving them weak Kool-Aid instead of strong
If I
Kool-Aid.
got 0.6-year-olds, we wouldn't have been effective at all.
No, no.
Okay, so that's like taking, that's like diluting like Rosartan or
Yes.
more than,
Mhm.
got it.
Yeah. Yeah.
A sitting class and it makes sense, but
Yeah.
I'm home going.
Yeah.
And then I've got notes from an hour-long lecture I watched on dimensional analysis. By the time I was done, I was so happy reading through the weight-based ones by time and all that, so happy. Got to the homework and the assignment and was just,
Insane.
what the heck? I could not translate it for anything, and not because you're doing anything wrong or the homework was crazy. I just was like, well, wait a minute.
It's like
Well-
once you get to doing it on the computer, everything you learn just, like, okay, what did Miss Wilson say about this? Can't remember.
Okay, so the good news is, we're not learning anything new today.
Yeah, okay.
So,
None of my face is sweating quite crazy.
It's just so frustrating. I think you get it, and then, you know, I just don't. And I don't understand what the big problem is.
okay, so let's go over some more. There's the eraser right in front of me here. Number 10 on chapter 10?
Yeah.
Okay. So let's start at number 7, because that's where the information starts. So it tells us, or it asks us what the usual dose for ceftazidime is. 1 gram every 8 hours. The intended route of administration is IV. It's stable for 1 week. So then it tells us, number 10, the provider orders 750 milligrams IV every 8 hours. Calculate the volume in milliliters to administer if the vial is mixed as described on the label. Okay? So I'm going to underline some things in my problem that I think I might need. So the order is 750 milligrams. And then I'm solving for milliliters. And then calculate if the vial is mixed as described on the label. So what does it tell us? What's our concentration that we're going to have? Add 10 milliliters of sterile water for injection for a concentration, because that's what we're going to need to calculate, is that concentration of
1 ml. 200 milligrams for 1 ml.
Okay. So I'm solving for milliliters. Start with milliliters. And for every 1 milliliter, I have 200 milligrams. I also know, so I've used this, my order is 750 milligrams. So I end up with 750 divided by 200,
3.75.
3.75.
And then,
What do we round to? Round to the nearest tenth. This is the tenth spot.
So it'd be 3.8, right?
Yes,
Okay.
3.8.
oh, no. And now we go, oh.
So you got the right answer until you rounded, right?
Yeah.
Okay, good. That's good. So just make sure you read the directions and round to the correct spot.
Oh, I'm wrong with that.
So the good news is that you at least got
Yeah.
the first right answer. You just rounded it incorrectly. That's an easy problem to fix.
Mm,
If you round incorrectly, that's an easy fix.
oh,
Okay, so let's find some more to practice with. Okay, see what we get. Let's look.
We do number 1 on chapter 10?
Number 1 on chapter 10.
Or did we already do that one?
Yeah, that's number 6.
Yeah, that's what we did on number 6.
Got it, okay.
Okay, so let's look. Let's go to, page 176 and 177. Try to work some of these practice problems. So chapter post test on 176, number 1. In all 5 of these problems, we're going to calculate milliliters and round to the nearest tenth. Okay, so number 1, a provider orders acetazolamide, 500 milligrams IV every 12 hours. The pharmacy provides acetazolamide in vials containing 500 milligrams. The vial label states that the contents should be reconstituted with 5 milliliters sterile water for injection for a final concentration of 100 milligrams per milliliter. So we're looking for the number of milliliters that we're going to draw up into the syringe. Okay, so solve for milliliters. I want everyone to work this out and see what you get, and then we'll do it on the board. So number 1 on page 176. Okay. What'd you get?
I got 5.
But I
I got 2.4.
I could do that in my head, so I don't know how to do the problem.
Okay.
I got 2.4.
All right. So we're solving for milliliters. Right?
Mhm.
So we start with milliliters on top. What do we have here? 1 milliliter contains 100 milligrams. Okay, I've used that info. I want to cancel out milligrams, so it's going to be on top next. Our order was for 500 milligrams. There's nothing else in relationship to that, so I'm going to put it over 1 to hold the place value. I'm left with milliliters on top. Everything else is canceled. Problem set up correctly, so I just solved. 500 divided by 100 is 5 milliliters.
Oh, easy. Very-
Too easy, I think, is the problem for some of you.
I don't know.
Yeah, at first I was thrown because it says the vial label states that the content should be reconstituted with 5 milliliters of sterile water for injection for a final concentration of 100 milligrams. But I was like, okay, that 5 milliliters of sterile water is not important. And then
It isn't.
once I got over that, I'm like, okay. And I read the problem and understand that it's to be like reconstituted with my answer. I was like, okay, that's right.
So if you notice what I've been writing up here, it's been the order of the medication by the doctor. It's been the concentration of the medicine,
And then
X, and it might be the weight. If they give us a weight, then that's important.
Wait, 'cause I got.
We're gonna get there.
Oh, all right, I'm sorry.
Okay? So order, concentration, 2 most important things. Possibly weight. So let's look at number 2. Provider orders azithromycin 250 milligrams IV daily. Comes in vials containing 500 milligrams. So that's our total amount in the vial. It must be reconstituted with 4.8 milliliters of sterile water for injection for a final concentration of 100 milligrams per milliliter. So what did I say? Order, concentration, and what we're solving for X, right? So what did we order? 250 milligrams. We have available 100 milligrams in every 1 milliliter. And what am I solving for? Milliliters. Okay, so this is the only information we're gonna need. Everything else is extra.
What do we do? And the way we constitute, just need the final concentration.
We need the final concentration.
So I'm getting confused about the extra info I think was so darn important.
You need the order, you need what you have available, and what you're selling for. What'd you get? 2.5?
So I just captured the other number that is not important,
Yes.
like 4.8, you know? That's like confusing.
Yes.
No.
So just remember your order, what you have, and what you're selling for. That's all you're gonna need. So the have is gonna be your concentration. And that's gonna be like milligrams per milliliter or milligrams per tablet, things like that. Okay. So in this case, we're solving for milliliters. That's what I start with on my top, and I've got 1 milliliter containing 100 milligrams. Cancel out milligrams. I've ordered 250. Cancels out milligrams. 250 divided by 100, and I get 2.5. Yes, try number 3. Okay. So number 3, my order was 500 milligrams. My concentration was 200 milligrams per milliliter. And what'd you get? 2.5.
And the next question is the grams and the milligrams.
Okay, so they're gonna throw us a curveball. So if it's involving grams and milligrams, what can you anticipate possibly having to do? Do the conversion factor, okay?
For the grams, right?
Right. So number 4, provider orders vancomycin 500 milligrams IV daily. Medication is mixed as directed on the label for a concentration of 0.05 grams per milliliter. Okay, so the order was 500 milligrams. And my concentration was 0.05 grams per milliliter. So solve for that one and see what you get. We're still solving for milliliters and rounding to the 10th. Okay, I'm solving for milliliters. My concentration is 1 milliliter, 0.05 grams. So I want to cancel out grams and leave milliliters on the top. So what else is left related to grams? Nothing, but it tells us that the order is 500 milligrams. So that lets me know I need a conversion factor of grams to milligrams. So I know that 1 gram is how many milligrams? Okay, so that cancels out grams. Now I want to cancel out milligrams, and I know that the doctor ordered 500 milligrams. Cancels out milligrams, milliliters are left on top. So I've got 1 times 1 times 500, 0.05 times 1,000 is how many? And I'm left with 10 milliliters.
The problem is just, you're not getting rid of the 30% community.
Correct. And I warned you guys about that last week, that that would be an issue. So we'll just have to continue to practice and practice.
Just not, now I know, but I just, when they put that information in there, it just assume, I just assume that it's important.
And you, why wouldn't you? I mean, you would think if they're giving it to you, it would be important. And it is important, but it's not important to the
Well,
calculation.
now it's important how we administer it.
Yes,
So now I need to know how many hours and all that stuff now, but
but not
not to get.
not in order to calculate, yeah. So do we feel more comfortable now doing some of these? Okay, now chapter 11 talks about calculations using weight and body surface area. Now the good news is we are not going to go over body surface area. Okay? So for a beginning nursing student or an LPN period, it's good to understand what body surface area is. However, in the real world, if you are administering medication to a patient that's based on body surface area, the physician will actually calculate that and calculate the dosage of that. So it's just important for you to be able to double check his or her work in order to do that. So we are not going to go over body surface area. So do what? Sometimes, yeah. So page 183 through 191 or 192, you are not going to be responsible for, okay? So we're only going over page 179, 180, and 181. And then 82 and 3 have practice problems. So we've already done these, a few of these already in previous weeks, right? With the body surface, or the weight-based calculation. So, so it says calculating dosages based on body weight. Medications may be prescribed based on an individual's body weight. Before calculating a dosage based on weight, make sure to weigh the patient using a dependable scale. Don't rely on the weight that the patient states, because we all know we like to tell little white lies about how much we weigh, right? Home scales may not be accurate, and patients may under or overestimate their actual weight. Ask a pharmacist or another nurse to verify your calculations prior to administering medications based on body weight. If your calculations do not match those written in the provider's order, obtain clarification from the prescribing provider. So, the first example, a provider orders Angiomax, 0.75 milligrams per kilogram, IV 1 dose today. The patient weighs 74.6 kilograms. Calculate the dosage in milligrams that the nurse should administer and round to the nearest whole milligram. Okay? So we're rounding to the whole number. Okay, so what is our order? Doctor orders
0.75.
what do I have available? I don't know, right? Patient, in this case, there's no concentration. Patient weighs 74.6 kilograms. And I'm solving for milligrams, right? So milligrams equals, what does it tell us in our problem?
0.75.
That our order is 0.75 milligrams for every 1 kilogram the patient weighs. I want to cancel out kilograms. And the patient weighs 74.6 kilograms. There's no other information related to that, so we're going to put it over 1 to hold the place. Kilograms cancel out, milligrams is remaining. So 0.75 times 74.6.
That's easy.
And I'm rounding to what? The whole
Nearest
number? Nearest whole number, so what does that round to?
56.
56 milligrams should be how much I'm going to administer.
Not too bad.
So you don't have that concentration?
No, not in this case.
Okay.
Just like, remember the simpler problems, like you're supposed to give 750 milligrams of acetaminophen and you have 250 milligram tablets available. How much would you administer? Same difference, kind of. Okay, example 2. Provider orders aminophylline 6 milligrams per kilogram IV every 8 hours. The patient weighs 65 kilograms. Calculate the dose in milligrams of aminophylline the nurse should administer. Round to the nearest whole milligram. So, what is our weight?
65 kilograms.
What's my order?
6 milligrams per kilogram.
And what am I solving for?
Milligrams.
Okay. So I'm solving for milligrams, so that's what I'm going to start with. Milligrams equal. My order is 6 milligrams for every 1 kilogram. A patient's weight is 65 kilograms. There's no other information related to that. My kilograms are canceled out, milligrams are remaining, so my problem's set up correctly. So what's 6 times 65? Told us to round to the nearest whole milligram, is that correct? Yes. Too easy?
Oh, no, I got that right, but the third is a whole milligram, right?
That's already a whole milligram,
Okay,
so,
sorry.
yeah.
Oh, no.
Yeah, it's already a whole milligram, so you don't have to round because it's already rounded correctly. Yeah.
Knowing what the canceled out is really helpful.
Okay, look at Example 3. Provider orders rifampin 5 milligrams per kilogram. IV every 12 hours for 4 days. The patient weighs 84.1 kilogram. And I'm looking for how many milligrams I'm going to administer. So I'm solving for milligrams. So milligrams equals, I know that I've got 5 milligrams per kilogram. I want to cancel out kilograms, so it's on top next. My patient weighs 84.1. So 5 times 84.1 equals
420.
So I'm going to administer 421 milligrams. Is that rounded to the whole number? Yes.
Oh, yeah, measuring out half a milligram of each.
Well, we're just supposed to round.
Times that.
And there's whole.
That's easy as it is.
It is on that side until, yeah. Okay, so let's look at example 4. Using the dosage of rifampin calculated in example 3. Calculate the volume in milliliters of rifampin that the nurse should administer, given that the pharmacy supplies rifampin in a 40 milliliter vial that contains 25 milligrams per milliliter. Okay, so we already calculated based on the patient's weight. The doctor said, okay, you're going to give your patient 5 milligrams of medicine for every kilogram they weigh. Right? And we determined that our patient would get 421 milligrams of medicine. So I know how many milligrams I'm going to give my patient, but I need to know how many milliliters that is so I can measure it and give it to the patient. Okay? So now in example 4, we're trying to figure out milliliters, right? So I'm solving for milliliters. Okay. And then my doctor's order becomes, my answer is 421 milligrams. Okay. And then what do I have available to give them? What's my concentration or availability of that medicine?
25.
25 milligrams for every milliliter. Okay. So if I go to solve for milliliters, I know that I have 25 milligrams contained in every 1 milliliter of medication. I want to cancel milligrams, and I know that the doctor has ordered that 421 milligrams, because that's what I figured out how much I have to give. So I've used this information, I've used this information. My milligrams cancel out. 421 divided by 25 equals 16.84. What does it tell us to round to? The nearest 10th. So this is the 10th spot. 16.8. That's my final answer. Now, if you look at the note on the bottom of 181, common mistake in dosage calculation is assuming that all of the information that's offered in a question must be included in the calculation. We've already decided that's an issue today. So for instance, in example 3, number 1, the question asks about the number of milliliters to be removed from the vial for each administered dose. Therefore, the frequency of dosing, it's telling us every 12 hours or 2 times a day is how often we're going to give that dose, is irrelevant in this case. It doesn't matter. We don't need to know that information at this point. The question does not ask how many milligrams or milliliters of medication the patient is getting each day, but each dose. If we needed to know each day how much total they're going to get in one day, then that would be important because we would have to figure out how many doses per day. But we didn't. Number 2, the total volume of the vial, 40 milliliters, is also immaterial information. It's only useful for determining if one vial will provide enough medicine for the prescribed dose. So it's nice to know information, but it's not necessary to know that in order to calculate what we were doing at the time. Number 3, the number of days that the medicine is to be given is also of no importance since we're calculating milligrams and milliliters needed per dose, not over the entire course of the prescription. So when calculating dosages, it's vital to know what information is relevant and what information can be disregarded. Read the question carefully, use analysis to set up the equation properly to help reduce errors. So if we focus on what the doctor's order is, what medication we have, what availability we have that medication, and then what we're solving for, if you focus on those 3 things first, and then see if any of that other information is necessary. And as we move on throughout the semester, there will be some times where we need that information. We need that additional information. For example, if we're giving a patient 500 milligrams a dose, it might ask us, say, every 6 hours, it might ask us how many milligrams per day would they be receiving? And that's when that every 6 hours would be important. Okay, but in these simple problems, it's not. Clear as mud.
That's really clear.
That actually explained, I should have done that before I took my exams.
Yeah, and that's why, I tried to explain it. It's just so hard, like I mentioned last week or the week before, without that nursing judgment that you guys don't have developed yet because you're not in nursing school mainly. It's hard sometimes for you to realize what important information is and what is not necessary. So just through practice and repetitive calculations, you'll get there. So focus on your order, what you have available and what you're solving for, and then go from there.
Sometimes concentration and sometimes weight.
Yes, yeah,
Relevant.
yeah,
Okay.
just depends on the problem. Okay. You guys feel better? Okay. So this week, we're only doing chapter 11, and then that will give you a little more practice on some of these basic calculations before we get into IV therapy and IV calculations next week. Okay?
That test is coming up, it says it's going from 1 to 12.
Yeah, I moved those dates this morning, so that's not going to be next week.
For clarity, when you say from 1 to 12, you mean the entirety of chapter 12, we're going up to chapter 13, so 1 to 12.
Yeah. So we're not even going to look.
And
We're
then
not.
there's a chapter we can do, isn't there, or is that was nutrition, never mind.
Okay. Any questions so far? Okay. So chapter 11 this week.